Hi, everyone, and good evening. I'm Dana Thompson, the director of the Brown Planetarium here at Ball State University, where I am. But we have two people who are not at Ball State this evening, two invited speakers joining us on Zoom to talk all about asteroids. We have Nancy C. Wolfson and Jeff Woytach here, and I'll go ahead and turn it over to Nancy to let her introduce herself and why she's here to talk about asteroids tonight.
Hi, Diana. Well, thank you so much for having us today. Jeffrey and I are very, very happy to be here with the Ball State University, Brown's Planetarium. Thank you for having us. So, Asteroid Day, what an amazing time to get us together to talk about asteroids. So, let me tell you a little bit about asteroids before we go, and then I will let Jeffrey introduce himself. So, Asteroid Day is celebrated on June 30. Why? Because is the United Nations sanction declaration to raise awareness about asteroids. Also, we are commemorating the Tunguska Event, which happened in 1908, June 30, 1908. So you're going to have this, and we will talk about this declaration later on in this presentation, and how we have signing this declaration many scientists, engineers, physicists, astronauts. We have over 125 astronauts joining us in this effort for this specific declaration, which was signed in 2016. So
Okay,
what
so
we're looking for, yes,
So
go ahead.
Asteroid Day is on June 30th, but it's not June 30th today, is it? It's July 13th.
No,
So we're a little
today,
behind, right?
today is July um, 13,
Yeah.
2021. And we are still in the middle of a pandemic, a global pandemic. How interesting. I think this is the best opportunity to talk about asteroids because having the pandemic in front of us show us that there are so many natural disasters. Well, the pandemic is, who knows what is its origin yet. It's still under investigation. But talking about disasters, global disasters that impact everyone, um, having a natural impact, you can say that is the only one natural disaster that can be prevented.
Great. Well, thanks, Nancy, for being here. Jeff, tell us more about yourself and what you're planning on talking about today.
Sure, Dana. I'm Jeff Woytach. I'm an aerospace engineer by education and a systems engineer by profession at the NASA Glenn Research Center in Cleveland, Ohio. Just a couple of weeks ago, as a matter of fact, I observed my 38th anniversary with NASA. So it's a pleasure to be here with both of you talking about this tonight. Thank you for the opportunity. Appreciate it. Um, as Nancy alluded to, this is a very important topic. Just like dealing with the COVID-19 pandemic, it is a worldwide issue. And dealing with near-Earth objects, near-Earth asteroids, and the hazard they represent to our planet is in that same vein. It threatens us as a planet, not as an individual nation, an individual state, but as a planet.
Yeah, asteroids too. Yeah. So let's back up just a little bit. What is an asteroid? Because we talk a lot in the planetarium about comets, meteors, meteorites. We have all these different names for things. Jeff and I were talking before we went live here about why do we need all these names? Well, Jeff, what was your answer on that?
So, you know, as human beings, we like to put everything into nice, neat little files. So we give this a name and that a name and that a name. But whether we're talking about meteors or asteroids or comets, they are, as I refer to them, the remnants of creation. They are the leftovers of the protoplanetary disk that existed around the sun, of which formed the sun, and the remaining material came together because certain areas of it happened to be denser than others. And as a result, the gravitational field was higher. And that high gravity started pulling in more material and eventually formed the planets. But there were still a lot of pieces of material left over from when the planets were formed. And that's what the asteroids are. They're the leftovers. that were not made part of the planets in the solar system.
Yeah, so these asteroids, these like rocky bodies in space, mostly between the orbits of Mars and Jupiter, they're just hanging out there, but sometimes they can get a little bit close to planet Earth, and that's what we're trying to really understand and make sure that we know their orbits and make sure Earth is safe from it. So, Jeff, why don't you go ahead and start with your presentation here and explain how do we protect ourselves from these objects in space, these asteroids? Again, rocky objects different from icy comets, different from meteors, which are much smaller coming through our atmosphere. These asteroids that we can really get a large impact from if they get too close.
Absolutely. All right, let me go ahead and share my screen here. And everything looking good?
Looks great on my end. Thank you.
All right. You know, as I said, what we're talking about as a planet is protecting our home from what we look at out in space. When we tend to look up into the night sky, we see this lovely velvety blanket perforated with stars. And we tend to look at that blackness as emptiness, but it is anything but empty. Our solar system, the sun and 8 major planets, most of them have moons. Jupiter now has 80 confirmed moons, and over 80 at Saturn. But you have the other material in the solar system, asteroids, comets, other bodies. They're the leftovers, as I said earlier, that did not become part of these planets when the solar system formed. You have the main asteroid belt, which exists between Mars and Jupiter, which is in all likelihood the remnants of a planet that never formed. You move further out into the solar system, at just past the orbit of Neptune, which is about 50 times the distance from the sun to the Earth, which we refer to as an astronomical unit. You have what's called the Kuiper Belt, named after the astronomer Gerard Kuiper. It consists of objects that are like Pluto. In fact, Pluto is a Kuiper Belt object. There are objects there that we know of that are larger than Pluto, that have orbital periods around the sun measured in thousands of years. And then going further out, 2,000 to up to 200,000 times the distance between the Earth and the sun is called the Oort cloud. Again, it's named after the astronomer who theorized it, Jan Oort. And this is believed to be the realm of the comets, that through gravitational perturbations, they tend to wander into the inner solar system. But other than these belts, there are other objects, other asteroids that are of particular worry to us. And these are objects that cross Earth's orbit around the sun. This is a graphic that shows a close-up of just some of these objects that are considered potentially hazardous asteroids, or PHAs, because of their orbits and their size. They represent a danger to Earth. And as you can see, this is pretty crowded. And this is not all of the objects that cross Earth's orbit and represent a danger to us. In fact, NASA set up a planetary defense office. They maintain and coordinate professional and amateur astronomers around the world who look for these objects, spacecraft that are searching for these objects. And in 20 years of observation, we know of about 20,000 near-Earth asteroids and over 100 near-Earth approaching comets. Of those asteroids, almost 900 of them are bigger than a kilometer in size. That's bigger than about a half a mile in size. Almost 2,000 of these are potentially hazardous, meaning that they're large. They're large enough to cause problems for the Earth. If they come through our atmosphere, they can survive to reach the surface. And almost 9,000 of these are over 140 meters in size. That's almost 500 feet across. In fact, in 2018 alone, over 70 of these objects passed closer to the Earth than the moon is. And we didn't know any of these were there until they had actually crossed. An example of what these can cause was evident in 2013. A meteor fragment exploded in the air over Chelyabinsk, Russia. It was small, about 20 meters in diameter, and weighed only 12 to 13,000 metric tons. That's about 25,000 pounds. It entered at a speed of almost 20 kilometers per second, almost 12 miles per second, was brighter than the sun. It exploded in the air with a shock wave equivalent to 500,000 tons of dynamite. About 1,500 people were injured from the blast effects, from the shock wave, from this blast, and over 7,000 buildings were damaged. Now imagine an object this small, which went completely undetected until it exploded in the atmosphere. Imagine if this explosion occurred over a major population center: New York City, London, Rome, Tokyo. Imagine the devastation of that explosive shock wave equivalent to 500,000 tons of TNT. Imagine the damage that could cause. So an object does not have to strike the Earth in order to be a hazard. As Nancy mentioned, Asteroid Day, proclaimed by the United Nations, is commemorating the explosion of a stony meteoroid fragment about 200 feet in size over Tunguska in Russia. It flattened tens of miles of forest, about 80 million trees, and over almost 900 square miles of forest. It exploded in the air. Again, it was not a densely populated area, fortunately. But if we go backwards in time, we see the evidence on Earth of much larger impacts. The Chicxulub crater is an impact crater buried beneath the Yucatan Peninsula in Central America. It was formed by an asteroid that was about 6 miles across, hitting the Earth 66 million years ago. The impact, the resultant ejecta of material that was thrown into Earth's atmosphere, basically dimmed the sun for many, many years and caused the extinction of 75% of all life on the Earth. In Germany, there is a city called Nördlingen, which is at the center of an impact crater. It's estimated that this was an impact from an object about 1.5 kilometers across, or about a mile across, hitting the Earth at about 45,000 miles an hour with a power almost 2 million times greater than the atomic bombs that were used in World War II. That is an almost unfathomable amount of energy. So clearly, all of these objects are dangers to the Earth. So we want to learn about them so we can defend against this happening again. We know that Earth has been bombarded. All we have to do is look up at the moon and see the evidence of bombardment across our solar system. Every planet in the solar system, Mercury, even Venus has craters, Mars has craters. The moons of Jupiter, Saturn, Uranus, and Neptune all have evidence of craters. They all have evidence of impact of this debris left over from the creation of the solar system. NASA has a spacecraft called OSIRIS-REx, which was launched in 2016. It went to one of these near-approaching asteroids called Bennu. It arrived there in 2018 and was maneuvered to actually retrieve samples from the surface of this asteroid to return them to Earth. That's the picture you see in the top right of your screen. Quite a bit of samples were obtained by the spacecraft, and they were buttoned up in a return capsule. The spacecraft left Bennu in May of this year, and that capsule with the material is due to come back to Earth in September of 2023 for analysis here on our planet. One potential way of dealing with asteroids that may impact the Earth is, of course, tracking them so we learn about their orbits. But if we find one that is in danger of impacting the planet, there is the possibility of impacting it with another object in order to deflect it, to push it into a different orbit. And believe it or not, NASA and the European Space Agency are going to test that theory. In November of this year, we will be launching the Double Asteroid Redirection Test Mission, or DART. DART is going to a near-Earth approaching asteroid called Didymus. Didymus is very small, but it has an even smaller asteroid orbiting it, like a small moon. That asteroid is called Dimorphos. As a matter of fact, that asteroid just got its name this year. DART is going to impact that small asteroid at a speed of almost 75,000 miles per hour. And then we'll look and see if that impact resulted in a deflection of that asteroid's orbit. If it does, we know that this is a potential defense for our planet. To really understand the problem is to understand our place in the universe. This is a picture of our solar system taken from the Voyager 1 spacecraft before it left our solar system. The spacecraft was commanded to turn around and take this picture. And in it, on the left side there, you see a speck. That one speck is Earth and Venus. And the quote here from Carl Sagan sums things up very well. Every civilization, every person that ever existed or ever will exist, existed on that speck of dust suspended in a sunbeam. Earth has been impacted and life has been extinguished on this planet through the impact of asteroids. It is not a question of if it will happen again. It is a question of when it will happen again. That's why we maintain a planetary defense office, to try and track these objects so we can determine if there is a potential hazard and ways to combat that hazard, like impacting that asteroid when it's far enough from Earth so we can deflect it, turn it away from impacting the planet. Because even an object that doesn't hit the Earth but explodes in the atmosphere can have devastating consequences for life on this planet. All right, with that, I will stop sharing and I will turn the floor over to Nancy C. Wolfson, and she will talk about Asteroid Day and her role with the International Astronomical Federation. Nancy.
What about now? Okay. Some technical issues that we are just all getting used to. So yes, Asteroid Day, what an amazing skills to get us all together in 2021. So let me see if I can share my screen now. I'm still getting this ready. And most of the presentation, we are going to leave it for the Q&A so we can have a discussion. So let me go to the first one. Diana, you let me know if I'm sharing. Apparently I am, but not quite yet. Okay. Okay. Let me try that again. Sorry, everyone. Almost there. What about now? Okay, so let me try this into a presentation. How's that? Okay. Hi, everyone. So I'm Nancy C. Wolfson. And first of all, I want to say thank you so much again for the Bell State University Brown Planetarium for hosting this virtual Asteroid Day event 2021. It's still in the middle of a pandemic. I'm so glad everyone can see us from their own homes. Nobody have to travel. I guess we're saving in tickets, especially for someone like me that travels back and forth, especially from Europe to the United States for work. But here we are. We're still in the middle of this, but nothing can stop us. And we can continue collaborating to bring space activities to everyone. Like always, it is great to be here with Jeffrey for this road show, as we said before. And today is all about asteroids and celebrating Asteroid Day. So in my case, just a little disclaimer. For everyone watching, I want to be mindful, and because this might be the first time that some of you are exposed to this kind of information, I will be touching some of the basics. Okay, so planetary defense 101. I hope to make this presentation as inclusive as possible. So let me see if I go to the next one. Oh, okay. What is Asteroid Day? Is the UN-sanctioned global awareness campaign on June 30, and we are commemorating, as everybody already said, the anniversary of Tunguska asteroid impact over Siberia, Russia. Unfortunately, but thanks to Tunguska event, we are more aware that a coalition of Earth with a near-Earth asteroid is no longer a science fiction movie. It has become a real threat. NEOs and NEOs that are closer to Earth and crosses its orbit poses a real threat to us and for life as we know it. These are the ones that we want to keep an eye on, the ones that get closer to Earth, and those are called near Earth objects and near Earth asteroids. I'll show you a little map later how they look like and where they are located. We already got some of that information from Jeffrey. The good news is that we do have the technology to predict their orbit by 100 years in the future, but we haven't found all of them. So we continue searching and discovering new NEOs. Now, what I want you to keep in mind as you follow this presentation is that an asteroid impact here on Earth is the only natural disaster that we could predict and prevent. We will go back to talk about Tunguska, and I will share some details complementing what Jeffrey has already shared with us. So let's go to the next one. Oh, going backwards. There you go. So this is a little bit about me. I am the vice chair of the International Astronautical Federation, and you can see my email right there. We are dedicated to continue raising awareness about the danger of asteroids and how can we protect planet Earth from an impact. And in case of an impact, what is there to be done? And as an international issue, we are always looking for opportunities to enhance the international collaboration in planetary defense. And I am also one of the signatures for the Asteroid Day Declaration, along with other engineers, scientists, astronauts, and space experts. Now, protecting planet Earth from asteroids. So as you see here, the extinction of the dinosaurs. Scientists are confident that a large asteroid crashed into the Earth approximately 65 million years ago. And most scientists now agree that the Chilliwack contains evidence that a huge asteroid or comet crashed into Earth's surface, causing the extinction of more, as Jeffrey said, more than 70% of the living species on the planet, including the dinosaurs. The asteroid was the size of at least 10 kilometers, as you know, but it crashed in the Mexican peninsula. So now, what I want you to know about this is that we are not the dinosaurs, and the dinosaurs didn't have a space program. So we're in a better shape, okay? Because most of the near Earth objects that approach Earth were not in our atmosphere. But this is what happens with the ones that don't, okay? So sorry for the dinosaurs without a space program. So let's go to the next one. Okay, so this is my map. You see all those little green dots, and you see those arrows pointing at the center close to Earth, and you can see Venus, Mercury, the Sun, Mars, and the main belt asteroids, and Jupiter. So we already shared with you a little bit of what is this danger of asteroids, because these objects can collide with Earth Asteroids are also important for having significantly modified Earth biosphere in the past. The probability of an asteroid striking the Earth and causing serious damage is very remote, but the devastating consequences of such an impact suggests we should closely study the different type of asteroids to understand their compositions, structures, size, and future trajectories. The more we know, the better prepare, and we can prepare and plan ahead. As you can see, all those green dots, that's the main belt asteroid. But if you go inside, crossing that, you will see that that area where the arrows are pointing, those are called NEOs and NEAs. Now, what is a NEO? Again, it's a near Earth object that is closer to Earth. What is a NEA? At the bottom, you can see it, is a near Earth asteroid, which is one of the asteroids that is getting closer, that are closer to Earth, somehow in our orbit. Okay, so here we go. Why the studies of asteroids? So now asteroids are a danger in case of an impact, but also there are very different reasons why we want to continue studying asteroids, not just because of that. The scientific interest in asteroids is due largely to their status as a remnant debris from the inner solar system formation process. Another reason, some studies shows that asteroids are possibly a possible source of organic matter. It could serve as a source of water, fuel, and oxygen for ships going through and beyond the asteroid belt. So all of this is still under study. What about asteroid mining? Will there be any benefit about asteroid mining for humanity? Well, let's think about if we can get some water resources. This can enable a large scale exploration of the solar system. What about metal resources? So probably Jeffy, you can talk to asteroid mining a little bit during the Q&A. What about we can use all of this to continue growing our Earth economy? So those are the things that I want you to think when you think about asteroids or near Earth objects. So scientific knowledge and be a spacecraft that could be more cost effective than the current systems we have now. So, and so this is the declaration of, this is the General Assembly. So on 6th of December 2016, the United Nations General Assembly proclaimed proclaimed in a resolution A71492 that International Asteroid Day will be observed annually, as you already know, when? Yes, you got it, on June 30. I'm just pretending that I'm hearing you. I'm hearing you. Okay, we're gonna give you a quiz after this. Okay, so remember this. Why? Why are we celebrating this? Besides remembering Tunguska Event, because we want to continue raising public awareness about asteroids and the danger of an asteroid impact. Okay, now if you see right there at the bottom, you can take a screenshot because you have the link to the official document that was signed by our experts. And in page 4, you will be able to find this, which is a little chunk of all the different pages that we have in the Declaration for the United States. And number 9, as you can see, let me move this here. So if you are like me, I like to go to the sources. I like to learn how and why things are happening. So if you go back into the link that I gave you and you read this document, in page number 4, you will be able to find this. Now, number 9 talks about planetary defense and near Earth objects, but the declaration is on number 10, which says it declares June 30 as the International Day, okay, and the anniversary of Tunguska. Now, at the top of that, we have also, and I'm just going to read a little bit, not the whole thing, but just a little bit for everybody before I end my presentation of today. Here. So, reiterates the importance of information sharing in discovering, monitoring, physically characterizing potentially hazardous near-Earth objects to ensure that all countries, in particular developing countries, with limited capacity in predicting and mitigating near-Earth objects are aware of potential threats. And this is something that we're still working, like how we are going to enhance our international collaboration. What about the communication processes that we have to bring the information on time in case of a threat, right? Also the management, how we are going to manage in case of an asteroid impact. So we're going into planetary defense. And in case of an impact, are we ready? Are we ready for an impact? Because this can have regional and global consequences. Also, there are two different organizations that were set up during this declaration, which is the International Asteroid Warning Network, I1, and Space Mission Planning Advisory Group, which is SEMPAGE. And they were implemented to provide recommendations for an international response to near-Earth objects impact threat with the support of the Office of Aerospace Affairs, serving as the permanent secretariat for the Space Mission Planning Advisory Group. That's SEMPAGE. So if you want to get more information about SEMPAGE and I1, I will give you more about it in the next, as we continue with this presentation. So is there an evidence of an asteroid hitting the Earth and exactly where it hit us? Yes, there are many. As you can see in this one, this map is showing us, you see all the little dots on the map? So those are the ones that has been detected. We have hundreds. There is not just one impact. We have hundreds of craters that has been already detected and were found. So let's go to the most known, I guess. So now craters are not all the same. And in fact, there are many differences between craters that provides a lot of information about how a crater was formed and when they were formed and why. So you see on the, what is my right? The one that says Varian crater. Okay, so this is a meteor crater, also known as the Barrier crater. You can see the name. It was in Arizona and was the first crater discovered to be formed by an extraterrestrial impact from a meteor. And it might have the impact, the asteroid might have been about 150 feet wide, traveling more than 20,000 miles per hour. You see the left one, which is the Bedford crater, is one of the largest crater verified so far. And this one is located in South Africa. It's the largest known impact crater on Earth, almost 200 miles across, over 2 billion years old. It is also one of the oldest one because the erosion over this long period of time, the crater is almost fading. So it's a little difficult to see. So now you have it. And let's go to the next one. As Jeffrey said, asteroids not only bombard Earth, but they have created craters all over our solar system, such as Mars, the Moon, Mercury, etc. So this is just one photo for you to actually observe and see the evidence that asteroids are always touching something. What about the Chilabut? So we talk about this crater, right? You see at the bottom, and this is what we consider that wipe out the dinosaurs, which is located in the Yucatan Peninsula, and is named after the nearby town. Part of the crater is offshore. Can you see the photo at the bottom? You will see that part of the crater is offshore and part of it is on land. The crater is buried beneath many layers of rocks and sediment. Now, this crater was discovered by Antonio Camargo and Glenn Penfield. I think Penfield, that's how you pronounce it, geophysicists who had been looking for petroleum in Yucatan Peninsula during the late 1970s. So this crater is now visible at the Earth's surface, like the famous meteor crater of Arizona. But however, the two surfaces expressions of the crater. So let's go to the next one. And I wanted to show you how, the crater is in between land and water. Okay, let's go to the next one. And yes, this is the Tunguska event. We're not going to repeat this. We already know. I just want you to go and focus on the top left on your screen. You can see a map, and on the other side, you can see that that's approximately the size that Jeffrey gave us, which is the size of Washington, D.C. So that is the asteroid that we believe was responsible for the Tunguska impact. Go to the next one. Now, the Chelyabinsk. So that's another crater. And as we said before, there are so many craters produced that you can now see from land. And so this one, the Tunguska event in 1908, let me see. So this is what it is. Sorry for the first one. It created a lot of damage, literally. So one of the things that we want to remember, and we're going to leave most of the information for the Q&A, one of the things that I want you to remember is when you see these photos, these are real photos from amateurs and people that were that witnessed this event, which is the Chelyabinsk in Russia. If I'm not mistaken, in February 13, 2015. And the damage that created this event really brought to everybody's attention why we need to talk more about what an asteroid impact is and the importance of continue searching and discovering near Earth objects, and how can we prevent this from happening again as a global community. Here, I just wanted you to know a little bit more about some other missions, some other planetary and near asteroid missions, so such as Rosetta. Then we have the Hayabusa 2 by JAXA, and we have the ERA by ESA. So I'm leaving a lot of stuff for us to discuss after this. Now, this is the 25, let me move this here. So you see, these are the different asteroid missions, and Jeffrey and I will be discussing this during the Q&A. So in 1996, one of the first ones was the near Shoemaker. Okay, in 1998, we have the Deep Space One. 2003, we have Hayabusa. By 2004, we have Rosetta mission. Then 2007, we have the Dawn. 2014, the Procyon. 2014, we go back to the Hayabusa 2 from JAXA, and then OSIRIS-REx, as Jeffrey already spoke a little bit of that of OSIRIS. And then 2021, great news, DART. We're going to be learning more about DART. Now, what is coming? future asteroid missions or planetary defense missions. We have, and we call it planetary defense because anything that has to do with the studies or study of asteroids could potentially help us to protect Earth from asteroids. Okay, so in 2021, we will be looking at Lucy. Then we have the NIA Scout. In 2022, we have Sight. And 2024, we have Hera, and Hera will be following DART. So we will talk about these missions in a little bit as I go to the Q&A, I think now. Okay, I'm almost at the end of my presentation. This is my favorite part, when I give you homework. So one of the biggest issues that we have, and I'm sorry because I see something on my slide. One of the biggest issues that we have in the NEO community and the planetary defense community is how can we deal with fake news? So nowadays we have internet, we have social media, and people just feel like posting whatever. They hear something and that they posted and it becomes, what is it, viral, and then everybody thinks that that is what it is. So as the experts and the professionals that are actually working this field, we're concerned. We're concerned about misinformation. So one of the things that I want to raise awareness about is where to go for the trusted information. What are the trusted sources that we have? And these are some of our organizations where you can go into their websites, and they have multiple places where you can find resources and updated news. If you are doubting that something might be real, like an asteroid is coming tomorrow, oh no, slow down, don't worry, we can predict, okay, these impacts. So I want you to go to any of these amazing organizations and look for the real information. So of course, one of them is the Planetary Defense Coordination Office, NASA, which Jeffrey already spoke about it. Now we have the United Nations, which is the Office for Aerospace Affairs, UNOSA, and in coordination with a program that is called UN Spider, that is only dedicated to disaster management. And they have an amazing information on their website that you can go. Then we have ESA. What is ESA? ESA is the European Space Agency, and they currently very, very much involved in planetary defense. Then we have I1, which is the International Asteroid Warning Network. And at the bottom, you can see SEMPAGE. We already spoke a little bit about SEMPAGE. They are mostly dedicated to the legal and policy aspects of planetary defense. And last, we have Asteroid Day. They have amazing information for you. This information is constantly updated. So if you wanna learn more about asteroids and planetary defense, these are some of the places where you can go and get the information from the experts directly. Okay, and as you see, Asteroid Day is celebrated internationally. Luxembourg just started their own asteroid mining program. So they are raising awareness, they are talking about it, and they are in the process of developing a comprehensive program in regards to asteroids. So these are just one of the places, some of the posters that I collected for you, so you can see that Asteroid Day is an international annual event. And let's go to the last one. And this is what I want to say. Thank you, Diana. Thank you, Jeffrey, for having me today. If you want to learn more about asteroids, feel free to contact me, or planetary defense. Feel free to contact me at nancyplanetaryDefense@gmail. And this is me. So now I'm ready for the fun part, Q&A. Thank you, everyone.
Thank you so much, Nancy. Thank you, Jeff, as well. If you're just joining us, I'm Dana Thompson, the director of the Brown Planetarium at Ball State University, and we have two invited speakers who just gave amazing presentations all about asteroids for Asteroid Day, which is on June 30th. But it's not June 30th. We still do Asteroid Day events all throughout June as well as July. And there's a lot of information on the website, which you can find in the chat that I put there for you all. So if you do have any questions for us at this time, make sure to put them in the chat. We'll get to them. But I will always have questions until basically people start signing off here this evening. So let me jump into mine here. At the end of your presentation, Nancy, and Jeff, you mentioned it too, we talked about that DART mission. We actually have a short planetarium program that we show groups here about the DART mission. Trying to understand if we can impact an asteroid's orbit right to maybe protect Earth from potential impact in the future. It says that in the timeline that you showed, Nancy, it was for 2021. Is that still the case? I think, Jeff, you mentioned that there's already some work being done there, but I heard that the timeline got pushed back a little bit. But where are we at on that?
Yeah, the timeline did get pushed back, and the current launch date is November of this year.
Yeah.
The spacecraft is fully assembled, has gone through its testing. The next step will be completing that testing, packing up the spacecraft, and shipping it to the launch site for integration with the launch vehicle.
And what is interesting about DART is that it's in coordination. NASA is working in coordination with ESA.
Yes.
ESA is the European Space Agency, which is going to be launching, if I'm not mistaken, 2024 ERA mission. So basically with the DART and ERA mission, ESA and NASA working together, we are going to be able to see for the first time a before and an after picture.
Exactly. Exactly right. Yes. Yeah. Hera will observe the impact that DART had on Dimorphos, and also look at how it managed to deflect the orbit of that small asteroid around the larger asteroid Didymus.
I think that it's wonderful that there are so many space agencies working together. I mean, it is an international effort, it's an international concern. And we have space agencies working together on things like the International Space Station up in orbit around our planet. Is there other international efforts? I mean, I know that a lot of the space programs, sending rovers to Mars, we use technologies that were created by other space agencies all the time. It's not just NASA, but I feel like a lot of what we hear about in the US is a lot of NASA, but as you know, we have so much coming from the European Space Agency, JAXA, and so on, to really help us with these efforts.
Yeah, you're exactly right. It's not just the United States, it's Europe, it's Japan, it's China, it's Russia as well. Uh, the Chinese have recently returned samples from the lunar surface, and they are planning another mission to actually return samples for the first time from the lunar far side. And those samples are in agreement with the world. They are being shared with the world. The Japanese Hayabusa missions, the samples from the 2 asteroids that those spacecraft visited that were returned to Earth are being shared around the world. As a matter of fact, I just saw a news article the other day where the first samples from Hayabusa 2 from Ryugu reached the United States. And we have curation centers at the Johnson Space Center in Houston. And again, those distribute to sciences, to academic organizations and scientists in the United States. And those exist in Europe and in China and in Japan and in Russia. So it is a worldwide effort. All of these scientists and engineers come together at conferences and exchange information openly. The petty political boundaries that exist between us don't exist when it comes to issues such as this. So it is truly a cooperative effort.
Yeah, there's no
Definitely,
political
yes, because
boundaries as seen from space. When you look down on Earth from space, you don't see those boundaries, do you?
No, I've always thought it should be a requirement that the leader of every country should be required to fly in space to see really what they're dealing with and how little the squabbles mean in the long run.
yeah, because at the end of the day, the space treaty, right? It says for all humankind.
Yes.
So, and we have to remember that planetary defense and the study of asteroids, at the end of the day, is a multidisciplinary, interdisciplinary area. So we definitely need each other to understand all the different aspects of researching and studying them, understand them, in knowing what to do in case of a threat. So it's not just one of us, as all the countries are getting together with their different space programs. It's also people, is the experts, the engineers, the physicists, the scientists, the educators. Education when it comes to asteroids and planetary defense is crucial, especially now. It's so vital to have our general public informed and how they can get more involved with this effort of protecting planet Earth from asteroids.
All right, we have a question coming in the chat here. They don't want to be assumptive, but are there any risks to the DART program going wrong and potentially sending one of the two objects to us rather than away from us, and maybe to another planet? So what are maybe the ethical considerations there of sending things to other planets? And then what if something goes wrong and something hits us?
Um, DART is going to be impacting a very small object that is orbiting the larger asteroid. So the energy imparted, I mean, when you consider a spacecraft weighing about a ton impacting an object at almost 100,000 miles an hour, that is a significant energy exchange. But when you're looking at a small asteroid, that by itself probably weighs millions of tons, the deflection of its orbit is not going to be noticeable. What we'll have to do is track it via other spacecraft like the Hera mission will do, and it'll also be tracked from ground observations. And by tracking it, you can then mathematically determine its path, its orbit. And you know what that orbit was before the spacecraft impacted, so you'll gather information on how it's moving after the spacecraft impacted and look at the differences. And that's how we'll know. There is no chance whatsoever of being able to deflect that little moonlet and it causing a problem for the Earth. Just like when we send spacecraft, for instance, to Mars, we worry about what could that spacecraft do to Mars. The spacecraft go through a process of sterilization that basically kills every microbe that exists on that spacecraft before it is ever launched from the Earth, to make sure that we do not contaminate these worlds. Samples that we're bringing back from these asteroids, and eventually samples we'll be bringing back from Mars, will be very, very carefully sealed, protected, such that even if their parachutes don't open when they're returned to Earth and they impact, that there is no danger of contamination. Not until they are opened in a controlled environment in a laboratory, where we can assure that there's nothing there that can harm us, or vice versa.
Yeah, I think that, there's protecting other worlds and, of course, our own, but there's also protecting the science, right? We want to make sure that we don't think we find something that was really something that came from Earth in the first place.
Precisely, yes.
All right, they say thank you. It's much more reasonable than what their imagination came up with. And our imaginations can kind of get away from us sometimes, which is great because we get some really nice ideas from all of that.
Unfortunately, some of those bad ideas, Hollywood doesn't help.
Exactly.
Yeah.
This is where we're taking science fiction to real life
Yes.
with this kind of educational programs on
Yeah.
asteroids and planetary defense. Yes.
Yeah, because when people think about asteroid belts, they might think of the Star Wars scene where they're flying through an asteroid belt. They have to dodge a lot of things, but there's actually more space between two asteroids than there is between the Earth and the Moon. So we fly spacecraft through the asteroid belt all the time. Space is very, very large, and there's a lot of empty space within it. But of course, things do collide with one another, and we need to be prepared for it.
Yeah, it was a number of years ago now, 20 plus years ago, where we observed a fragment of an asteroid impacting Jupiter. It was torn apart by Jupiter's gravity, and we saw it impact. And since then, we've seen other objects impact Jupiter. Um, there's a European spacecraft called the Solar and Heliospheric Observatory, SOHO, which has been operating since, I believe, 1998. And it has observed hundreds of objects impacting the sun. It got a little too close. The sun is a big gravity well, and it just pulls them right in, deflects the orbit, pulls them right into the sun. But there are literally millions of objects out there. Some we track, some we can't track because they're too small for us to track. But technology continues to develop. We continue to develop new methods and ways of tracking these objects, and the technology keeps progressing.
Oh yeah. We have several telescopes constantly searching.
Yes, absolutely.
Mm-hmm.
And
What's
you know, one of the best evidences for impacts of the Earth we see every night. It's called the moon. The moon was created when an object impacted the Earth, when it was still molten, when it didn't have a surface, when there was no life on the planet yet. And the material that was thrown into space coalesced to form the moon.
So how large does an object have to be detectable with our current technology? Because you said technology is getting better, but what's the maximum size or minimum size that we can find?
It's probably between 50 and 100 feet, but again, it depends on the distance away from the Earth.
Yeah.
Um, the way you find a lot of these objects is that a telescope takes a photograph of a section of space and then photographs that section of space days or weeks or months later. And you look at the two photographs and see if anything has moved. And you're literally looking for a speck that has moved. In
So,
fact, amateur astronomers have taken NASA data and found near Earth objects that NASA and other space organizations have missed. Um, and there have been objects that have been detected by amateur astronomers as well. So that International Asteroid Warning Network includes these amateurs as well as the academic organizations, NASA, and the space agencies. And it is a world event because we're all human beings. We can all miss something.
Yes, and don't forget about the citizen science programs that we have in regards to asteroids and planetary defense. One of them is the Unistellar set up by SETI, which gets amateur astronomers looking into the skies and discovering new asteroids. And they actually discovered not too long ago, if it's not a year or so ago, a new one. And what you do when you discover these ones, then you try to understand them, and eventually you give them a name so we can continue tracking them. And so amateurs and citizen science programs are so important in nowadays because we are living in the 21st century where we can get our people involved in scientific projects. So we don't have any more excuses to have that division between us, the experts, and the general public. This is when we can actually join efforts and understand these kind of events as a community, as a global community.
so it depends on not just the size of the object, but how close it is, and from what I'm understanding, how reflective it is too. Because if it doesn't reflect a lot of light, if it's maybe made of this material that doesn't reflect light as well, then you're not going to see it shine in your observations, right?
Yeah, absolutely. A lot of these objects are are covered with organic materials, carbonaceous materials, and they're as dark or darker than coal. They don't reflect a lot of light. When you see these images from spacecraft of some of these asteroids, they look very bright. Well, that's because those images were taken over a long period of time. The light levels and how much light they reflect is actually very low. But we need a certain amount of light to see, so we take care of that with photography. But some of them are, you're correct, they're actually very, very dark objects.
All right, so speaking of excuses, Nancy, there's a question in the chat that says, or really just a comment that says they never really heard about the DART program before. And why is that? Like, why haven't people heard about it? I know there's so much going on. There are so many products out there, but marketing and advertisement is
Oh,
really
yes.
important. Or what can we do to kind of help get the word out there a little bit more?
Good question. Good question. As you see in one of the slides that I show, there are so many missions. DART is not even the first one, right? So, as you said, why we haven't heard of DART and why we haven't heard of all the different missions that we had previous uh, to DART? Because unfortunately, again, there is a big disconnect between our communities and the general public. And this is why more and more the experts are understanding that it is our responsibility to create those platforms to include not just some, but everyone. Because at the end of the day, especially in planetary defense, in a case of an impact, who is going to deal with that impact? Not just the experts. We need an educated community to understand what to do in a moment of such a disaster. So what can we do about this? Well, we need to continue blasting what we do. One, the different organizations that are working and collaborating and collaborating in different efforts for planetary defense internationally, such as I1 and PAGE. Obviously, we have NASA, ESA, which is the European Space Agency. Then we have also Asteroid Day, which is dedicated, and this is why Asteroid Day, as the nonprofit, was formed, because there is a big need to continue talking about this. And it's not a matter of waiting for everybody else to knock the door and be like, what is going on? It's for us to get out of our conferences, to get out of the books and the reports and the different work that we do daily, and step out and create those platforms that are public, for public education. So I definitely put a big chunk of the responsibility on us, the experts, because we are the ones that have the information and we are responsible for everybody to have the right information. So in case of a disaster, we can all coordinate efforts as a community and not just as individual organizations or individual people or individual communities.
Okay, so say someone goes online and they see a post about an asteroid coming very soon, and it's not fake news. It didn't just go viral because things happen like that sometimes.
Social media,
It's social media, yeah.
Instagram, or
Um,
Twitter,
and
which is the new one.
yeah. So, and they see this object coming to Earth, like the one in Russia. There's a lot of people watching out windows and looking at this amazing event. But what happens when that shockwave comes and shatters that glass and they get
Yeah,
injured? So, what are some kind of quick tips of saying, off, in the off chance that there's an asteroid or something
very easy.
impacting? Yeah.
Oh yeah, very easy. I know we want to look at that window because we see something shiny and we want to know what it is. The first thing I can recommend is just a step away from the windows. Okay, because the shock wave is actually the one that is going to cause most of the damage uh, as it's going by. So I guess that will be my quick recommendation. But I want to follow, I want to give the floor to Jeffrey, because I'm actually curious about what he can tell us about this, and then I will complement that. Jeffrey, what do you think? You can tell us what we can do in case of.
If that ever happens, and most communities have a warning system of an impending problem, a disaster, where it's on social media, it's on television, it's on radio, and you have an early warning system. The thing to do for something like the Chelyabinsk incident is to take cover as if you would if a severe storm was moving in your area, a hurricane, a tornado. People who live in areas that are prone to earthquakes will understand. You take cover where you are not exposed. That is what you have to do, because you could potentially be dealing with something, as we saw in the charts I presented, that could literally have the explosive power of an atomic warhead. That's not an understatement. That's not a statement out of science fiction. That is a fact. It doesn't take a heavy object to cause damage. When we were flying the space shuttle orbiters, an orbiter had a window severely damaged because it struck a flake of paint. When the paint is moving at 17,000 miles an hour in one direction, and you're moving at 17,000 miles another in the other direction, the kinetic energy is mass times the square of the velocity. The velocity is big, the mass may be small. Now imagine an object that weighs tons or hundreds of tons moving at 30,000 miles an hour. The energy is almost beyond comprehension. Is with like dealing with a hurricane, dealing with a tornado, dealing with an earthquake. Take cover where you're not exposed, where you're protected. It's probably the best advice that we could give you.
And try to verify the information.
Absolutely.
Yes.
The early warning systems would, if possible, give notice of something happening. And in talking about finding about information, everything that NASA does is available on the internet, www.nasa.gov, and from there you can get links to many other things. Go to your local planetariums and talk to the planetarium directors. Go to your local science museums, natural history museums, talk to someone there. They can give you a lot of information. And just go to your library. Do a search on the internet for asteroid missions. And I guarantee you will pull up a lot of information on past, present, and forthcoming missions to asteroids. The information is all out there. Sometimes you do have to hunt for it because there is so much out there. But NASA is probably one of the biggest users of the internet. Everything NASA does is there.
Yes.
You can pull down the latest information that came from the Perseverance rover on Mars today, and take a look at it. Scientists and engineers across the world do it all the time. The information is there. Don't be afraid to look for it. And every NASA webpage has contact information at the bottom. Don't be afraid to send an email. Fill out those contact forms. Ask for the information, because you will get it. You will get it. That much I will guarantee.
Now, Jeffrey, you will agree with me that we also don't want to create panic. Okay, it's probably easier. I don't want to say easier, but it is rare to have an asteroid impact. Okay, it is possible. We know that it had happened. It will happen probably again. But dying from a airplane crash, is probably is more often than having an asteroid impact. So right.
It's much more dangerous getting in your car and driving to your local store to get a happy.
Exactly.
Yeah.
Exactly. So we don't want to create panic. So one of the things that we like to do is we want you to be informed, but also we don't want you to be running away and thinking that tomorrow is going to happen. No, again, Asteroid impacts is the only natural disaster that we can predict and prevent.
And
Of
actually,
course, under the right circumstances. Yes, Jeffrey.
if you want to see a very pretty light show from objects impacting Earth's atmosphere within the next couple weeks, we will have the Perseid meteor shower. It is amongst the most active. Any given night, if you're in a dark place, you will see little streaks of light as these pieces of leftovers enter Earth's atmosphere and harmlessly burn up. There are impacts on this planet on a daily basis. Fortunately, they're small enough that we don't notice them. But again, we're it's like being in Las Vegas. We're playing the odds, and sooner or later, the house wins.
Yeah, I was gonna say that something that is more common or something we can see even tonight even is a shooting star or a meteor. So a little leftover bit from a comet entering our atmosphere, compressing the air, getting heated up, and we see this streak of light. Of course, like an asteroid and why people were looking out those windows for the impact in Russia most recently is because it made a really, really big streak of light in the sky. Um, so I have a question going back to the dinosaurs because no one
Ooh.
loves anything more as a kid than space and dinosaurs. So why not talk about both of these things in one session? Um, when the asteroid impacted Earth, it entered the atmosphere, compressed that air. We call that ram pressure, right? And it heated it up. And there was this idea that it heated the atmosphere up and almost like baked it like an oven, created an oven surrounding our planet. Is that something that we should also be concerned about? Not just the impact, but the temperature rise from the atmospheric effects from these impacts?
Yeah, absolutely. I mean, the impact itself would happen at such an energy that the object itself, the majority of it would be almost vaporized as soon as the impact occurs. But the energy released in that process, as you said, it will heat the atmosphere, and spreading out from that impact would be um, basically a firewall, turning the atmosphere because the air can't get out of the way fast enough as this shock wave is progressing. It heats up to a plasma, incredibly, incredibly hot. And that, of course, would spread out. And then the blast wave itself, just like any explosion, it's compressing the air. If you've ever heard the sonic boom of a supersonic transport, for instance, that sonic boom is the same thing. It's a lot lower energy, but it's the atmosphere being compressed and that shock wave spreading outward. And then you have the fact that you have an explosion that is forcing the atmosphere outward. It's creating a vacuum. So the air is going to start rushing back in, and then all of this debris is pulled into it and thrown into the atmosphere. And it spreads through the atmosphere and it blocks out the sun. It can block out the sun for decades, for even hundreds of years.
And
Go ahead.
yes, and this is what happened. I mean, it's believed that the impact that wiped out the dinosaurs actually covered darkened the skies for about 3 years. So you can imagine what is going to happen to the life that needs a sun to continue as us, obviously, to continue moving forward and existent. So yeah.
Yeah, there have been large volcanoes on Earth that have had massive explosions, massive eruptions, and thrown particulate matter into the atmosphere, and actually has caused dimming. In the 1800s, the Krakatoa explosion, and in the 1980s, Mount St. Helens in Washington State. It actually did cause cloudiness and dimming of the sun for weeks afterwards because of the fine dust particles suspended in the atmosphere. It all had to settle out over time.
And wasn't there like a no fly recently just because of a volcano explosion
Yes,
eruption I should say. Yeah.
yes, yeah. You have all this very fine particles in the atmosphere suspended. And if an aircraft, a jet engine flies through those, it's ingesting all of those and the engine can't operate.
Hmm. Okay, we're a little over on time, but I have a couple more questions if you don't mind. So I know we have all these groups trying to work together internationally for asteroid protection. Um, Sometimes it's difficult on just one small committee to communicate, right? So how do they communicate with one another? How do all these different groups communicate in a way where they're not stepping on anyone's toes? If there's asteroid, there's not too many people going to the one at a time and interacting or affecting other people's science. How does that work?
Well, Jeffrey, you want to go first, or should I go?
No, go ahead, Nancy, please.
Well, one of the things is, so a big part of my work is dedicated to international cooperation. So there are different processes that we use, and one of them is to have these constant, continuous meetings. We are in constant communication. As you said, how do we do to not step in anybody's toes, right? Well, it is important that cooperation, especially internationally, is based on communication. It's based on openness. It's based on the desire of wanted to collaborate in future efforts, initiatives. And DART and HERA is on a larger scale is an example of that cooperation, of that international cooperation between ESA and NASA. Now, on a more logistical level, we have the United Nations helping us, always monitoring all the different organizations that we have, providing help, support, and not just in terms of like in case of a disaster, but preventing that disaster based on collaborations that happens on pretty much on the daily basis. I mean, people that is dedicated to this area, which is the study of asteroids and planetary defense in any of the different sectors. As I said, this is an um, interdisciplinary area. We all constantly looking for ways to communicate with each other and see how can we enhance each other's work. So it takes a lot of openness to want it to work together. And it happens. It happens. I mean, I'm sure Jeffrey will tell us. We are in constant communication, creating new initiatives, new platforms to continue talking about this. Then we have, of course, let me list it quickly. UNOSA. We have I1, which is the International Asteroid Network, as Jeffrey said, that is constantly communicating with all these different organizations, including NASA. Then we have the space what is it, the Space Society, I'm mixing it up.
The National
What is it?
National Space Society?
Yeah, well, the National Space Society, but we have another one besides Asteroid Day that is dedicated to raise awareness about asteroids and planetary defense. um, but anyway, I'm sure if you go back to my slide, you will be able to look at it. So yeah, my short answer is it takes uh, active communication with one another and creating initiatives and opportunities where we can continue learning from each other.
Great. And also communicating it to the public too after everything.
Absolutely.
Yeah. Okay, one last question, I promise. And it's a
All
fun one
good.
because Jeff, I saw in your bio that you are a fan of Star Trek, like a lot of space nerds are. And there is a Deep Space One mission back in 1998 that I saw. Was there a Deep Space Two or Deep Space Nine?
There was a Deep Space Two. Deep Space Two was carried on the Mars Polar Lander. It was an impactor that would have entered Mars' atmosphere and actually survived impacting on the surface and buried itself beneath the surface to do subsurface measurements. Unfortunately, both the Mars Polar Lander and Deep Space Two had failures, so they never reached the surface. Um, where Deep Space One was a very interesting mission. It was actually a technology test bed. It was the first time that an ion propulsion system was used as the main propulsion system on a spacecraft. And ion propulsion was invented in the late 1950s, yet it was not used as main propulsion until 1998. And now asteroid missions like Dawn, which went to both Ceres and Vesta in the main asteroid belt, could not have been done any other way other than with ion propulsion systems. DART will use an ion propulsion system as well in reaching its target. And the Psyche spacecraft, which is going to the main asteroid belt next year, will also be powered by ion propulsion.
That's amazing. Okay, well, we will leave it there. Jeff, Nancy, thank you so much for your time and your expertise in informing us about this really important topic. I really appreciate your time.
Thank you
And
for hosting us, Dana.
yeah, absolutely.
Dana,
And
thank you so much for having us today, and thank you for the Bell State University's Brown Planetarium for hosting this amazing event on
Yes.
Asteroid Day 2021 on July 13th.
And we'll put a link to that in the chat for you all so you can go to that website. Again, I already put it up, but it's gotten pushed up with some of the questions and the thank yous that we've been receiving. So thanks everyone for watching. Again, have a great evening and take care. Bye bye.
Thank you. Good night.
Thank you. Good night.